Good day, class. You are with Malakwe Jafta once again. We are going through a sewer management design calculation. Let's take a look at the possible calculation that they might ask in this regard. In this case, they are saying to you, briefly explain, in fact, they are saying consider the community in Butterworth in the province of the Eastern Cape with the data that is provided, collected in 2019. The area is demarcated according to the levels of socioeconomic grouping as shown in one of the tables provided. Then the F numbers have about 4 dwelling units, which is very important because we need to be very vigilant now when we speak of the 4 dwelling units. If you talk about 4 dwelling units in the F, consider the dynamic of this community, as it is said that the dwelling units have been declining quarterly from June 2009 with 5% for each socio-economic grouping due to the attraction to big cities, as there was to be a soccer World Cup. All manholes are indicated as manhole 1 and manhole 2 respectively, with a water course with 15% infiltration. Also consider the sewage from informal settlement nearby of 1.8 liters per second are contributing to manhole 2. And as per the drawing reflects, due to the minimum budget designed for only the expectations from the 1st of August of September 2011. The rest will be dealt with in the next financial year is to come. So that is the statement. They are saying to us we must determine the peak wet weather flow discharging into the existing sewer line by the 1st of September 2011, as the data is sitting from 2009 and declining with 5% due to the 2010 Soccer World Cup. And we noted that we've got an informal settlement contributing at manhole 2, cited at 1.8 liters per second. Now, each of the demarcation is as per figure 1 below. Now, when they look at figure 1 below, they're actually giving you the socio-economic grouping. That tells you that the lower number of Fs is 25, middle is 20, high is 15. Average flow liters per unit per day is 550, 750, and 900. Number of people per unit is 6, 4, and 3. We're going to explain that as we go within the calculation. And then you come now to the drawing itself. Now when you look at the drawing, that's what the drawing is saying to us. We're only going to do manhole 1 and manhole 2. That's what we're going to design, and according to this, that is manhole 1 there. That's the line we're going to design for the flow, and the next one is there, and the contributing factor is expected to be 1.8 liters per second. From there, we've got contour lines across the settlements. The settlements are indicated as area A, B, C, D, and D. All right, we're going to go on now and start the calculation. However, we are going to make sure that we consider all the lengths of pipe expected to be 150 to 80 and so forth. All right. All right. As per the question is suggesting that we calculate the PWWF, which is the peak wet weather flow, expected to be coming out of the settlement and the structure that is provided. Now, according to the drawing that we've seen on the question, they are looking at plus minus that kind of environment whereby they say there is an illegal connection connection from there, and then and so forth. Yeah, that becomes manual 1. So what is expected here from us is that we start the calculation considering that what contributes to that manhole 1, and then we know what flow is expected, the worst case scenario flow, considering the peak wet weather flow. Now, when you start the completion, you do it in the format of a table from basic principles. We are going to do the line 1 as per the question was suggesting. The description of line 1, you simply distinguish to us what is happening, what are the contributions to line 1, which is draining A, which is draining A, draining B, and draining B. And then it's moving from manual 1 to manual 2. That's from manual 1 to manual 2. And then the sub area becomes A and B, which is A and B. Now, according to the question, they specify to you in terms of what is in A and what is in B. That is according to socioeconomic grouping, which is low income level and high income level. However, you'll notice that the days that you are finding here, the number of units that you find here being tabulated, are different from those that you find on the question itself. But we noted that on the question there was a declining rate of 5%, so that every population that is in this area is being affected by the declining population of the 5%. Because remember, we are given a data from 2009. We are using a 2009 data, but we are calculating a 2011 estimation. So if you look in terms of that and those calculations, and then you start effecting the 5% decline, then you get the values of 10 and 6. Then the average flow in liters per unit per day, 550, you leave them as they are, and 900, you leave them as they are. However, when it comes to the ADWF, that is where you start considering the formula for the ADWF, which is actually, you take the number of units, you times the average flow, which is the one that you've got there, and then you simply use the conversion for the days in terms, and then you put it into seconds, and then you get liters per second. Then the value for that becomes 0.06. I'm sure you are getting the idea now. And then the cumulative becomes the same because you are just moving across. However, as you do your calculations again, you do the same calculation. You take that value, which is the average flow, the one that you were given, you take it directly from the table, and then you simply effect it in that formula. And then you get your values again of, perhaps it's almost the same, about 0.06. And you get other values now of 0.06, 0.3, 0.13. Now if you combine those two, that's where it lands in us to 0.03. And then moving forward, then we take into consideration the issue of the number of people per unit. Now the number of people per unit again, remembering the fact that it's being factored or it's being affected by the decline in population, we need also to consider that from what we are given in the table of the socioeconomic grouping, you still get affected with the decline in population, and then you then move now to a state of saying, okay, I need to then effect the 5% decline in population and get the values of 5 and 2. And then for this one, actually, the number of people is 5 and 2, yes, correctly. And then for the number of people, for the number of people per sub area, you simply combine multiples of 10 and 50 and 5, and then you get your 50, and then you multiply that by that one, and then you get your 12. That's where you get your number of people per sub area. Then there will be total tributary population. For the tributary population, again, it's a cumulative. You take it as it is across, and then you simply add that one and get the 62 that you get here. So that's how far you consider it. But the only thing that I would say you need to give your heads up with is what they say with regards to the 2009 as well as the 2011. Because from there, you then have a audacity to effect the peak factor, because on the peak factor you look at the total population by which you follow that formula, And then from that formula, the P becomes a factor, becomes a number of people per thousand. From, for instance, from 2,500 population, you get about that person per day, factor of 2.5. Then you get your reading. So it's a matter of us affecting that peak factor, and then we can get the enough values. But you need to be cautious that when you're dealing with the peak factor, now the line is only simple focusing in this pipeline, because remember the tributary population was talking to that. So those are the important figures that we're looking at on the tributary population. So everything that we're looking at is sitting on the tributary population importance, because that's the majority of what contributes to the pipe. So we're considering the worst case, we consider both contributions, which is where they lie. They're on the tributary population. Then we get our peak factor. So for this case, our peak factor was 4.29, and then the PWWF. When you get the PWWF, which is the peak dry weather flow, you simply times your cumulative ADWF by your peak factor, and then you get your sum of 0.54. Now once you get your 0.54, again you then take your 0.54, you multiply by your peak factor, and then you can determine your peak wet weather flow, which is 0.06. That becomes your peak wet weather flow. Yeah, for now I'm going to leave it for this time being. I'm going to leave it there, but I'm expecting people to start loading questions, because some of the areas might be not clearly to everyone. So yes, let us leave it from there, and for more videos we can keep on engaging on the YouTube channel with Malakwich after. Then you can get more videos, and continuation of this video there will be another video which clarifies any questions that may arise based on this calculation. Thank you.